Hello, I welcome you all to your own channel MSQ Learning. This video gives you the information that how to solve the numerical problems which is related to the diesel cycles. So diesel cycle is having constant pressure cycle, heat addition is at constant pressure, heat rejection is at constant volume, and two are the adiabatic compression and expansion. So one question related to the diesel cycle is on the screen. An ideal cycle with air as the working fluid has a compression ratio of 18, means RC is given, and the cutoff ratio of 2, that is rho, is given. At the beginning of the compression, the air is 100 kilopascal, means P1, and temperature is 27 degrees centigrade T1, and the volume is 1917 centimeter cube, means V1 is given. Determine the pressure and temperature of the air at each point. You means you have to find out T2, P2, T3, P3, T4, V4. The next work done, thermal efficiency, the mean effective pressure, right? So for that, first of all, we will draw the temperature versus entropy diagram, and then we'll write down the given data. So let's start. So here you have a solution. So first of all, I'll write down the given data, that given data. So given data, you have an ideal cycle with the air as a working fluid has a compression ratio is 18, means RC is equal to 18. Cutoff ratio is 2, means rho is equal to 2. So here you can write RC is nothing but the V1 by V2, right? And the cutoff ratio is what? Cutoff ratio is V3 by V2. That also you know. The pressure and at the beginning the pressure is given, means P1 is equal to 100 kilopascal. We will keep it in 100 kilopascal only. And the temperature is given, that is T1 is equal to 27 degrees centigrade, means 300 Kelvin. And the volume is given, V1 is equal to 1917 centimeter cube. Okay, so these data are given. Now we have to, first of all, you need to calculate the T2, P2. Okay, and then we'll find out the T3 with P3. So first of all, we'll calculate that. You can say RC is equal to V1 by V2, right? So RC is equal to, that is RC is equal to V1 by V2, right? So it means that V2 we can get from here. V2 is equal to what? V1 by RC. Okay, so V2 we got, that is V1 is 1817 by RC is equal to 18, right? So we can see here, so 100.94 centimeter cube. This is the V2 we got. Again, you know that V1 is equal to what? V1 is equal to, V1 is already given, so you know. Okay, so first of all, we can draw the, here I'll forget to draw that TS diagram, then you can understand for the diesel cycle, right? So temperature versus entropy diagram we will draw, right? So temperature versus entropy diagram is what? That is first of all, adiabatic compression, constant pressure heat supplied, adiabatic expansion, right? And then you have a constant volume heat rejection. So 1, 2, 3, 4, right? So this is the volume is constant, the pressure is constant, right? And here the volume is constant. This is adiabatic compression and adiabatic expansion. So we have drawn the TS diagram. So if you look at, that means V1 V3 is equal to V4, right? Now V4 is equal to V1, constant volume. So V1 we already know, okay, that is V1 is equal to V4, which is equal to 1817 centimeter cube, right? So we got the V1 and V4 and V2. Now we can calculate the V3 also. Why? Because cutoff ratio rho is equal to V3 by V2. So V3 is equal to rho times of V2. So rho times of V2 is what? That V2 is 10.944 into 2. So we got, that is V3 is equal to 201.88 centimeter cube, right? So V1 V3 we also got. Now we need to find out the T2, P2, T3, P3, T4, P4, right? So first of all, we'll go and then we'll find out the T2, right? So 1 to 2 process you can say here, that is 1 to 2, T2 by T1 is equal to V1 by V2 whole power gamma. But that V1 by V2 is nothing but the compression ratio. So T2 is equal to T1 times T1 is nothing but 300, and this is RC, that is 18, and gamma will take as 1.4. So you have a 300. So T2 you have, sorry, gamma minus 1. It's a gamma minus 1, right? Yes, that is T2 is equal to 953.3 Kelvin. So temperature at the end of the compression we got. Now you can similarly you can find out the P2. So P2 is equal to what? P1 times of V1 by V2 whole power gamma, right? So P1 you have 100 kilopascal, so 100, and the V1 is 18 to the power of 1.4. So let's see, that is 100. So this is 5719. That overall you can say 5720, you can say, right? 5720 kilopascal. That is at point 2 we got the temperature and pressure. Come to the point 3. But you know the P3 is equal to P2. Why? Because it is constant pressure. So P3 is equal to P2, which is equal to 5720 kilopascal. So this is how we got the P3 also, P2, T2 also. So now you can find out the T3, right? So for T3 you can see 2 to 3 process. 2 to 3 means what? That is pressure is constant. So when the pressure is constant means volume and temperature are proportional to each other, right? So you can say V2 by T2 is equal to V3 by T3. Alright, so T3 we need to find, that is T3 is equal to V3, okay, by V2 into T2. V3 by V2 is nothing but the cutoff ratio. So T3 is equal to 2 into T2 is how much? T2 is 953.2, right? So we got the 953.2. Okay, so you got 953.2 into 2 is equal to T3 also we got, that is 1906.4 Kelvin. Okay, so that at point 2 and 3 we got the pressure and temperature. Now come to the 4 point, that is you can say where 3 to 4, you can take the 3 to 4 process. Okay, now 3 to 4 process you can take, and then you'll go to this. So you can write down 3 to 4 process, right? So what is the 3 to 4 process? That adiabatic expansion means we can say the T3 by T4 is equal to V4 by V3 whole power gamma minus 1, right? But the V4 is what? V4 is nothing but you have a V1. Okay, so this is you have a already all the values you know actually, right? So T4 you need to find, that T4 is equal to T3 by, we can say here T3 by V4 by V3 to the power of gamma minus 1. So you can substitute here, T3 is equal to 1906.4 upon V4 is what? V4 is equal to V1. V4 is equal to V1, yes, that is 1817 by V3 we calculated, which is 201.88. So this is the 201.88 whole power gamma minus 1 means 0.4. We can substitute and get that answer. So this is what you got. T4 is equal to 792, right? So our T4 T4 is equal to 792 Kelvin. So we got all the pressure, temperature, even at the silent point. Right, now you need to find out the work done and efficiency, right? So for that, so first of all we will see the heat supply, thermal efficiency, right? And then we will find out the network. So first you can say that is heat supplied Qs is equal to what? mCp, that is T3 minus T2, right? So mass we don't have. Mass we need to calculate, that is mass is equal to P1 V1 by R T1. So P1 is what? 100 kilopascal, and the volume is 1817 centimeter cube, right? So it will be meter cube. We need to take 1817 into 10 to the power of minus 6, right? By R is equal to 0.287 and the Kelvin temperature is 300 Kelvin. So this data you need to substitute. So your mass is P1 V1 100 kilopascal. So you got this mass is equal to 0.0021 kilogram, right? So this mass you got. Then heat supplied you can find Qs is equal to mCp, that is 0.0021, Cp is equal to 1.005, and T3 you have T3 is how much? Let me check once. T3 is equal to 1906.4 minus T2. T2 we calculated 953.23, right? So 953.3. So we got the heat supplied, okay? And then similarly we can find out the heat rejection. So first let me calculate this. 0.0021 into 1.005 and 1906.4 minus 953.3. So we got heat supplied as a 2.011 kilojoule, right? This much of heat we are supplying, and the heat rejection is what? That heat rejection you are doing from 4 to 1, right? So you can write at constant volume, that means mCv T4 minus T1, right? So m is same, that 0.0021, Cv is 0.718, and T4 you got just now 792, right? 792 minus T1 is given 300. So we have so you have a heat rejection is 0.741 kilojoule, right? This much of heat you are rejecting. So we calculated the heat supplied and heat rejection, right? Now we need to find out the network. So network is what? That is heat supplied minus heat rejection. So you can say W net, right, is equal to what? Heat supplied minus heat rejection. So heat supplied is where? How much? 2.011 minus 0.741. So you have a 2.011 minus 0.741. So this is your heat. W net is 1.27 kilojoule, okay? Network we calculated, that we got the network, okay? Next we need to find out the thermal efficiency. So we have a thermal efficiency, right? Thermal efficiency is how much? That neta Th is equal to W net by heat supplied. So W net is how much? 1.27, and the heat supplied is 2.011. So we got this, that is 63%, right? So you have a 0.63, or you can say the 63%. That is your thermal efficiency, neta Th. So this is the thermal efficiency we got. Next we have to find out the mean effective pressure. So mean effective pressure, how can you calculate? That is mean effective pressure, mean effective pressure. Okay, so mean effective pressure is, that is PM is equal to W net by swept volume. Swept volume means V1 minus V2. All the values you have, that is W net you calculated 1.27, right? And the V1 is what? V1 minus V2. V1 you got 1817, that is 1817 into 10 to the power minus 6, right? So 1817 minus this value you got, that is what? Then you have a V2 is equal to 100.9, right? 100.9, and then centimeter cube is given, so you have to convert this into meter cube into 10 to the power of minus 6. You will get the answer. So this is how you can execute the problem which is related to the diesel cycle. Thank you.